Hello and welcome back to another episode of Fixing F-150s. You might be thinking to yourself, wow, it's been a long time since your last post. But actually, no, you're wrong. This is me actively gaslighting you. That was actually yesterday. You sound just like your mother. Now, if we get to the important aspect, I wanted to go over a few of the highly incorrect things that I see even to this day in HP tuners. Time and time again, especially if you make the morbid mistake of asking any AI, most of the time other than OpenAI, but OpenAI does this too. So you'll see some numbers in mine that don't look like yours. And if you have a 3.5 liter F-150, you still might even see some either numbers that don't match or even entire tables that don't match again. It depends on what VIN number, what gen your engine is. I believe the 2015 is the first of the Gen 2. Yeah, but if you have a 5.0, I would honestly say that none of this applies to you. These vehicles are so wildly different. Now, Ford logics tend to be pretty close to each other in how they operate, so it's not entirely, but the aspects that I'm probably going to be touching base on today might not apply. But most of my experience is like 99% of it is with the 3.5 liter Ecoboost, not just in the mechanical side, but the tuning side too, right? So time and time again, you see the airflow speed density, and many people in the forums, I don't know if they're used to tuning Mazdas or Corvettes even, or maybe they're just used to using other EFI systems like a Holley EFI or something like that. But the problem with this speed density is that nothing happens in a vacuum inside of these vehicles, right? So you might be confused. Well, okay, what do you mean by nothing happens in a vacuum? So the moon sits in a vacuum in space, right? But it's not truly in a vacuum. It orbits the Earth orbits the sun and all that stuff, right? There's more going on here than just these tables telling you that, like, oh, your blow-through slope at optimum power is this value in this bizarre and only used here, unit, right? And that sounds all fine and dandy. But the problem is if you go into open loop or closed loop in your sensors here, after any of these points, right, these temperatures, the engine doesn't care what these values mean anymore. These values are totally ignored. Your sensors in the exhaust, that is your O2 wideband sensors that you can see in your logs, they're like the 4 bars, I believe, in the stock setup. They're going to be the source of truth, right? They're going to be what your truck identifies as, God's word, if you will. Nothing else comes higher. Now, they activate at certain load. So if you're going to be driving, occasionally if you like let off the throttle rather suddenly, or you just are kind of like at a stop. I think in idle controls, actually, yeah, if you go to idle right here, it's VSS speed. I think it's stock is 2 miles per hour. And I changed it to 3. Don't question me. I'm highly specific with what I want out of my tunes, and still they work most of the time. And that's a joke. The only thing I also see on the forums a lot is they always tell you to drastically change your exhaust flange temps. So let me go ahead and reload a stock. You'll also notice that I have 3 stock files. Always. HP Tuners typically tells you in their training videos to do 2 stock files. I like to have 3 stock files because it's so easy to be accidentally modifying one of those instead of your not stock files, and then you don't have a stock reference, and now you don't have the ability to flash the truck back to stock. So here you go. You can now see the changes that made. So this is your flange temp. So they're measuring, or they're not measuring the temperature anywhere. They're simply guessing the temperature based off of another table, based off of RPM and exhaust temperature. Now, how do they know the exhaust temperature? They're also guessing it, right? But it's not to say that their guesses are terrible. It's just like in my application when I'm running E85, or because of the current situation going on in the world, the E51. But I've changed all the higher values to be wildly higher than they're supposed to. And you should not do that if you have purely stock components on your vehicle. This is to protect your exhaust flange, it says, but realistically it's to protect your exhaust manifold, right? these exhaust flanges, I'm pretty sure, unless you're getting it as like O'Reilly's or AutoZone part, I don't think they're realistically having trouble. I pulled the turbos off and had them replaced a few months back, and I had those. I look at those flanges, and there's obvious signs of wear on the flange, don't get me wrong, but it's not destroyed. And I've been running those temperatures for at least 10,000 miles, and it's a 10-year-old flange. Still, the new flanges are in there and they're better, but the reason I'm doing that is because I have BD diesel exhaust manifolds. Now, this is one thing I am a stickler about. If A, you're already getting close to the 100,000 mile mark in an F-150 and you haven't changed the turbos, you probably should start thinking about at least saving up to, if you're not going to do it yourself, because it can be kind of expensive if you don't go to the right places. I mean, I think when I took it to Ford, they quoted me for $5,000. Like that's pretty high for a truck that's probably only worth 3 times that at this point. And you know, with the failed turbos. But honestly, I think your money's better spent getting a turbo upgrade kit, and then maybe running those turbos a little less. Is my logic, like buying better turbos that last longer and then just doing the elbow grease to do it yourself. Because in all honesty, I mean, the oil lines are annoying, but I mean, you can do it if you've got any kind of technical skill and a little bit of patience. You can definitely do it inside of a week. Just a couple things you got to know, like the bolts that hold the triangle of the 3 big T47, or the heck it is, bolts that hold on the turbo housing to the manifold are not reusable, right? You have to read these things. They have them in the manual sometimes, and then sometimes online forums are actually helpful. And then you should be able to tell, now this is a nuanced thing, but these bolts are interference fit, so they're designed to interfere, if you will. Essentially, the bolts have like a small bend in them, so as you tighten them, instead of having like a thread locker on it or a seize device, like a liquid or something, or just rust, I mean, after 10 years, these bolts are actually purposefully bent so that they don't fit the hole. The reason for that is so that they don't vibrate out, which also coincidentally means they can't be reused because they're torque to yield, and also they're extraordinarily difficult to get out. I would recommend getting an air gun or at least an electric drill with a high torque setting, like a plug-in-the-wall drill with a chuck for a 3/8 or a 1/2 inch. You're probably going to want one of those because I didn't have any power tools to do this, and it probably took me significantly longer. But yes, this is the other thing I see people do a lot, is they just completely outscale this. I wouldn't outscale this personally. I've changed the values at above 4,000 RPM because, well, if I'm above 4,000 RPM and I'm flooring it, it's probably because I want to go somewhere without really caring much about the manifolds. The next thing you're going to see a lot of people do is talk about the flex fuel side of things. Now, I will fully admit I haven't figured this out yet. But if I've spent a year tuning my truck and I'm decently good at this, I'm not a professional, right? I'm just a guy that's kind of figuring things out like an engineer. I have not figured this out. I've not made this work once. I think your best option realistically is to get a ethanol test kit, and as annoying as it might be, you spend the 1 minute after you fill up or whatever to reflash it. Now, generally speaking, you don't need to reflash it every time, right? If you notice that it has a stumble at idle, you might need to. But at least where I am, the E85 content doesn't really change that often unless there's a war going on in a oil producing country. So I typically would leave these alone. I'm still figuring these ones out. So if anybody on the forums claims to have this figured out, scrutinize the living snot of it, because this is a science, man. This takes a lot of learning, experimentation, and there's a bunch of little stuff too, like on the stock table. This is 6 here and 0 on top, and then if you change those numbers at all, they default to 9.8 and 9. It's weird. So little things. The other thing is people tell you to lean your mixtures out sometimes. I really don't like that. I'm never one to chase an additional 5 or 10 horsepower if it significantly increases the risk of knock. Your main priority on your vehicle should not be getting that last 5 horsepower, right? If you wanted 5 horsepower, you could do a world of things to these trucks. before and then you'd start needing ARP head studs or something like that. You do not like, this is actually somewhat enriched from stock level, just for extra safety, right? HP tuners always do that. They recommend it. I've never had a problem since changing these enrichment rates higher. I think that was just an EPA related thing. I couldn't tell you. The other thing that I've tested and seen failed over and over is just about every explanation for what the max load number means right there. I've heard people say that it's the manifold air pressure as a multiplier, like 1.8 or 180% of atmospheric. Wrong. It was at 198% atmospheric pressure at 1.74 load. So wrong. It's not that. I've heard a bunch of different explanations and none of them really seem to line up. So for me, that's still a toss-up. It affects stuff. I'm just not exactly sure how to predict it, right? I could come close, like saying, oh, well, if I decrease this to 1.6, it means I'm going to make only 14 pounds of boost instead of 18. But it's like, I'm guessing it's going to be off by, up to half a PSI. And that's not really an estimate. That's just a decent guess at that point, right? Because precision is something that you should really go for when you're going for, especially tuning your daily driver like I'm dumb enough to do. The second thing is people like to talk a lot about these map points. And these map points are a vastly complicated system. But the more complicated you try to make it, the more complicated it's going to be to tune. Now, I can tell you within a short range of time here of how this kind of works together after I completely miss it. So this is for your cams, by the way. Your cams have lobes in them, or think of them as walls, in a circle, lobes. And they serve as kind of like paddles, right, on a water wheel, but they're restricted in how much they can move. So it's not like it's free spinning like the water wheel in a river or a windmill. Instead, the engine uses oil pressure from inside of the engine, because you have oil pressure already made by the oil pump. So they're utilizing something that's already there, and they're squeezing it into this hole in your cams, and your cams are connected to a solenoid which pushes the oil into the cam gears. Excuse me. I don't know if 3.5s have oil coming through the cam themselves. That I don't know for sure. I've not taken the head apart in a 3.5 liter. But my point being is that they use the oil pressure from the oil pump and the engine to act as a water wheel inside your cams with pressure, right? Not with flow. That's the important distinction. And what they're doing is basically it's allowing the timing chain to rotate 60 degrees in advance on the intake side of the camshaft. So the crankshaft still turns at the same rate if everything else is constant. But now, because the oil pressure has filled those lobes and maxed out the advanced on the intake cam, it has maxed out the timing chain, which maxes out the valve timing on your intake cams, right? And your intake and exhaust cams can retard or advance and retard accordingly. I think the exhaust can gets up to like 50 degrees, but that's nuanced stuff. What I'm trying to tell you here is that what the engine is doing is that you have these tables here, so this is also important. This is at what, below these numbers, the engine can utilize this, right? So at 5,000 or 6,000 RPM, the engine is not allowed to use fuel economy. That's essentially what this is saying. And keep in mind also that this graph here is barometric pressure in inches of mercury, and a standard atmospheric day in inches of mercury, I think, is like 29.92. So, I mean, you're pretty much always here, unless you're in, like, I don't know, Alaska. I don't know what their barometric pressure is, but I doubt it's 1/2 of an atmosphere or 2/3 of an atmosphere. That being said, as long as this kind of if check, if you're a programmer, is true, that being if the number less, if the number less than this, you're going to go to here, and if load is 0.8 and you're at a state of 2,500 RPM, it can blend, so it can be 2,750. You're going to be at 6.5. This does not mean you're at mapped point 6.5. This means that this value of 6.5 gets translated over to this vertical table here, And this vertical table translates this arbitrary value into mapped points. Why they do it this way, I don't know, ask Ford. But 6.5 is actually going to be 5.5. So for your pain and pleasure there. And so that's how those are going to generally work. Now I have changed the base camming timing just ever so slightly. Again, I have very specific things that I'm going after here. So there's a reason I would do that. Don't just arbitrarily do that. But the other thing that I'm doing to simplify my tune is that I've the enable pedal position for optimum power is extraordinarily lower from stock levels, and then the percent load is too. So basically I'm telling the truck, hey, if there's boost almost at all, just balls to the wall as far as the cam is concerned. And that's going to be losing probably, I don't know, 3/4 of a mile per gallon on throttle, but I don't care. I just want torque. Because if you have a 3.5 liter and you've towed anything over 5,000 pounds, you know what I mean. And that brings us to our other point, transmission. I have seen numerous and fell myself for several of these terrible, terrible tuning advices. The first thing I always see, increase this boost pressure. I don't think one person that is not a transmission mechanic or actual like mechanic for occupation can tell you what that number means. And that number shouldn't matter to you unless you're doing something extravagant, because the transmission is going to tell the torque converter what the pressure should be, and it probably knows better than you. So I wouldn't touch that yet. There's better ways to do stuff with this, right? So all these numbers, that's nuanced stuff. I wouldn't touch those necessarily, because that's not really what's going to be controlling the slip that your torque converter gets. It does, but it's more nuanced than that, or more complicated. So I wanted the truck to be more snappy down low because it kind of feels sluggish. And then because I have more torque down low, because I have changed the fueling and the way that the turbos work and the turbos themselves, I wanted to change the speed ratio so it doesn't just push the engine up to 3,000 RPM and make 5 pounds boost to get the same torque it could have made at 2,000, right? So I changed the speed ratio and then changed the torque converter map accordingly. That's something you're going to have to learn to do, not something it's not something that you can necessarily go out and drive to do. I don't think that's realistic to dyno that. What I did is I just looked at the differences between the tow haul, the sport mode, and the normal after having driven in those conditions, and noticed what felt different. And then you can pick up patterns in the shift scheduling, and it's typically associated with downshifts. And that helped me a lot. But yeah, nothing on this side. Like these values, if anything, should be increased, especially if you're like me and you've changed the pressures of the oncoming and offgoing clutches. Now, the other thing I see with respect to this is people change these numbers. That's great. But it's kind of like painting the car before the chassis is on the frame. Why are you painting why are you painting the frame Ford flame and blue? Or blue flame, whatever they call it, right? That you're supposed to have the doors and everything on it already before you paint it. I mean, maybe you paint the doors, but you know what I'm saying. Why are you putting the icing on the cake before it's even in the oven? It's just gonna melt. This is the icing on the cake. This is the batter. You want to be changing these first. Now, the reason I say that, so the way that most, if not all, automatic transmissions apply pressure, or their logic at least, is that they take the torque the vehicle's producing, and they're going to multiply it by a slope. So it's your mx plus b math formula. If you feel overwhelmed by that, then good luck. The rest of the world's a lot more intimidating. But this is a linear function. So if you were to go into this, just to help you understand, right, and you're in third gear, that means if you're making 400 foot-pounds of torque, which is almost as much as the truck can do stock, and a max power output like 3,700 RPM or 3,300 RPM. You're doing 400 foot-pounds, and you multiply it by 0.28, and you get 112. Now, what does that mean? Does that mean that the solenoid is going to be pushing the clutch for the next gear at 112 PSI? No. That is the linear interpolation, because what you also have here is the intercept. So if you're also in third gear, so it actually means you're going to be pushing that solenoid at 130, was it 134? Yeah, 134 psi, because it's 112 plus 22.1. Now, why would they do it this way instead of just increasing the slope, right? Well, let's say that you're trying to shift without being on the throttle. The engine, depending on what your torque management is set to for your driver to man, could be a negative torque. Now, I've changed how drastically these negative values are because, again, I've changed the ratio of my torque converter. But if you go back here, and so sometimes your torque isn't just 0, it could be negative 12 foot-pounds. And if you're trying to do a shift in that state, well, telling the transmission that it needs to convert a positive value, a positive, expected positive value that is now a negative value into a pressure, well, the pump's not going to turn backwards. The pump's not connected to an electrical pump that can pump backwards, right? It can only go forwards. And so that's going to be a potential issue. And realistically, what that means is that you're not going to go anywhere because it's not going to command a negative 16 pressure and actually give it. It's just going to give you a 0 pressure because the duty cycle on the pump or whatever is just going to be 0. So they do an intercept so that at 0 torque, you make 22 psi. Handy, right? Now, realistically, at idle, you make, I think, in between 36 and 56 foot-pounds of torque. So realistically, you're seeing about a 50 psi, a 30 to 50 psi. But again, changes with everything. But the reason you want to change these first is, like I said, this is the icing on the cake, right? So you can change all these first if you want, but that's, I mean, wow, that's, first off, that's really time consuming. And second off, that's incredibly inefficient. And third off, that's just not the right way to do things. Now, if you do change these interceptor slopes, and these change the oncoming and off going at the same time. So when you downshift, it's the 3M and the 2M that shift together. Don't, again, not highly experienced in this area either. Do your own stuff. So I've quickened the shift and doing a couple of other things I had previously increased the RPM that was here to make the shift softer so that I could get the needle, if you will, on the RPM to drop significantly faster, and then I could slowly harshen the shifts back to a stock level feel, but they're like considerably faster. In fact, I believe in the shift pressures or shift properties, my bad, you can see it might not seem like a lot to you, but if you go to these higher values, I'm saving like, what is that, 0.04 seconds? And that's decent and significant, right? It may not seem like all that much, but I'm not dropping a sequential transmission or a dual clutch in this thing. This is still my daily driver. I'm not trying to kill it. I just want it to be a little bit snappier. And surprisingly enough to me also, even though this is the clutch fill time for these, the biggest change that I've seen happen, especially because the torque converter change itself also quickens the shifts, is it used to be when you were on the throttle and you got off the throttle, it would kind of get not necessarily stuck, but because the engine needed an X amount of time before the torque converter could lock or unlock or, you know, whatever have you, you would get, the engine would just take forever to finally get back down to that idle RPM. And if you're like me, you like efficiency and snappiness and all that good stuff because you're an engineer and you're driven mad by all these things that no one else is. And basically now, if you get up to 5,000 RPM and you let off, it's like bam, 1,000 RPM. Or if you're on the highway, bam, 2,000 because I have a 355 rear end. But yeah, don't change anything you don't know. It's okay to change some things small, but you have to know the basic underlying reason or cause of what you're doing. You can't just be like, oh, this torque transfer time, I want a quicker shift. Let's just multiply all those by 0.7. You don't have any idea what that may do. I mean, you may get, you know, the starry night painting in your oil drain or your transmission fluid. But yeah, that's going to cover most of the things that I see coming out of the tuning, just generally. The other thing that I see people do is they like to really push these pressures quite high, but there's a more important thing that I'm going to get to. So hang around. I have pushed these PSIs considerably higher than stock, but I've also pushed them higher than this. I've pushed them up to, I think, 3,500 PSI, and they don't get there. And you shouldn't try to get them there, but don't worry, these injectors are extremely well built. Um, so it's not smart to push them to 3,500 RPM. Don't get me wrong, but they'll work, and they'll keep working for apparently a very long time. And 3,000 is still, in my opinion, I would consider it safe. But at 3,000, they also lose a lot of their efficiency because they have the high pressure fuel pump itself loses volumetric efficiency as you go above that 2,200 PSI, right? Because the system is designed, all the hardware is designed to work at or around where it already is. They wouldn't design the high pressure fuel pump to work better at a higher RPM or a higher fuel pressure, because then they would just have it running at a higher fuel rail pressure. But this goes back to another thing that I see time and time again. People like to say that you either need an upgraded high pressure fuel pump or that you need upgraded injectors. Now, just like you won't be able to see a more aggressive cam shaft for the F150 because of the VCT system, you also aren't going to see very many injectors that are legitimate options for you as an F150. And that's for a reason. See, I don't know what other people are working with, if it's maybe 2017 or 2018 thing and after. Mind you, there are injector options for 2018s and after F-150s. I have not seen any reasonable injector options for my year of truck, because with the Dishworks ones, or how you say that, they're extraordinarily high flow. I mean, they're like 3 or 4 times the flow of my injectors. And if you do the math, because of the way that the pressure works, I would have to run my injectors at a dangerously low pressure at idle just to maintain the truck running at 600 RPM. And the reason that's dangerous is because gasoline dissolves oil. So if the pressure is really low and the fuel doesn't get to atomize, even on cold starts, like 60 degrees or 70-degree cold starts at this point, you're effectively running the piston rings in the block with no oil until you get a high cylinder temp, and that's just not really wise. But the moral of the story here is I have the same high pressure fuel pump. Hell, I have the same water pump that the truck came from the factory 11 now years ago. And I'm running E85 on 18 pounds of boost doing stock levels of air through the turbo, right? So I'm making roughly 405, 410 horse on E85. I don't think you need injectors. If you wanted to do more than that, you're going to need turbos that are better. And if you wanted to use those turbos, yeah, you need something. But to be honest with you, as much as the injectors cost and as much as the injectors do, I think you're better off doing something kind of more inclined to what I've done. And it also solves 2 problems at the same time. The F-150s that don't have port injection have a problem because they don't have port injection. That's the reason the new ones have it, right? Carbon buildup on the valves. So not a good thing. It means your valves can't do the closing thing. The whole thing they're designed to do is close and open. And that's not good. You want your valves to be closey and not loosey because of the carbon built up. Carbon's not just bad in the atmosphere, it turns out. And when you run E85 or ethanol methanol water mix over those valves, it's going to clean them up rather well. But the problem is that that's a tuning fiasco. I'm still trying to figure out the electrical work myself because I'm a tuner, not an electrician. But I probably have it figured out, probably. But I'm also schizophrenic with it, right? If I notice that the sensor ever reads 0 when the boost gauge doesn't, I don't like that, right? Because what can happen if you get an expected fuel flow that just quits, right? Well, now the engine's running lean at a high output of power. That's not smart. But that's what I would recommend. Get a boost cooler system and then just get a bigger nozzle, right? So if you need 13, or if you're doing stock injectors and you want to do 500 horsepower, just get a 14 or 16 gallon per hour nozzle. Now, obviously, start with a 6 gallon per hour nozzle and just work your way up. But what I'm saying, get your fuel system in your manifold, in your intake manifold. Don't put it in your cylinders. Your cylinders have enough fuel right where they are. If you can A, chill the boost down, and B, get more fuel in there, you might need ARP head studs from how much torque you can make. Now, I'm not making that much torque because I don't have incredibly high flow turbos. I only have like 7% on stock. So I can make 500 horse with a boost cooler system or boost chiller system. But I can also make 590 foot-pounds of torque. But I'm going to pull fuel out of those torque ranges so the torque level is a little bit more linear and not just, you know, like a diesel, like I have it tuned right now. But yeah, that's what I would recommend for the, like, and again, it costs the same amount as your high pressure fuel setups that people like to recommend, because you're going to need a high pressure fuel pump and injectors and fuel rails and the injector connectors, because all these things are extremely hard to take off together, right? Other than that, it's got 160 degree thermometer, so you'll see that my desired coolant temperature is lower and the fan speeds are different and the trans speeds are different because the transmission cooler other than that, I'm trying to think of any last things before I sign you off. I will say a lot of people like to talk about how much they can advance their spark. Some people boast they get up to 35 degrees now. I personally believe that's with a boost cooler system and E85 or methanol. I don't personally feel comfortable running my boost up or my spark up that high. So my 0.7 is a pretty good idea normally of what your truck's going to kind of be at a higher power output. For me personally, I see it bouncing around 11, 3, and 7. That's another thing that I see people do that I've personally never gotten much luck from is that when people go to these map points configuration and turn on map point optimum power, leave that off. If it was good, Ford would turn it on from the factory. It's not. It runs like crap, and you're going to have to tune that, and it's way more trouble than it's worth. The truck runs great if you do it this way instead, where you just change the distance tables that exist already. But yeah, going back to spark, people like to crank these numbers crazy high. And again, I'm not a fan. I don't particularly care about losing, like I said, even 20 horsepower if it means saving the head, right? Because there's a smarter way to do this too, right? You can get the fuel efficiency back of running on E85, and you also can take the advantage of the higher knock resistance and, you know, increase spark and increase horsepower. And one of the best ways I found you can do that is use the in-truck knock sensor. The truck already has a logic that chases knock, right? The truck already tries to adjust the spark tables to know when it does and doesn't knock, and then it retards a little bit once it experiences a soft knock. Soft knock is still not a great thing, but it's not knock. And you can change these tables themselves, and the truck makes the adjustment itself. So I may have on hot summer days, my spark advance might only be 12.5 degrees at, you know, wide open throttle condition, which is pretty retarded for an E85 setup, right? With 30 pounds of minute of air. Like, that's really cold boost or charge air temps for the F-150 3.5 liter. But on a cold day, it might be 27 degrees. I mean, it could be totally different. And that's because the truck gets to decide on its own, because I've widened that range. And the best part about that is it doesn't matter really what I put in here. This is a midpoint. The truck gets to decide, and the truck knows better than I do. And then it keeps it in the safe range that it was already in from stock. I'm just letting it utilize the octane. So that's about all I have to say on this one, because this video is getting a little bit long. But yeah, this is my second video. If you like this kind of thing, let me know in the comments, or if you're angry that I haven't posted in, well, too long, then you can also leave that in the comments, but don't expect an apology. I'm a college student, and I'm also kind of pull between a ton of different hobbies. I'm that kind of person, but yeah, leave a comment. Maybe I'll make a new video, but you know, maybe.